Welcome back to Trig P.10 and Pre-Calc 1.9 Part 2 notes. Again, we're dealing with the topic of inverse functions, and we're going to take a look at the graphs of some inverse functions and see the relationship that they play with one another. So if I asked you to graph f of x equals 2x minus 3, there's lots of different ways you can do it. You can plug it into the graphing calculator, you can look at this and say it's y equals mx plus b, graph your b and do your slope, or you can make a simple table with x and y values. I'm going to choose the table method because I want to show you the relationship between the x and the y values. So I just picked some x values. If we were to take the time to plug this in, if I plugged in an x of negative 2, I'd end up with a y value of 7. So we can plot that point, negative 2, negative 7 would be here, and we can keep going. I put a 0 in there, I get negative 3. Put a 2 in there, I end up with a positive 1. And put a 4 in there, I end up with a 5. So if we connect the dots, extend it off both sides, we'd see that this is what our graph should look like. Okay, let's do the same thing now with the inverse function. So I will, let's label these. This was the f of x. This would be the inverse. I specifically picked these x values on purpose. Notice that they're the exact same y values that I ended up getting when I used those x values and the function. So if I use these x values, look what's going to happen with the y values that I get. When I plug a negative 7 in, I end up getting a negative 2. When I plug a negative 3 in here, I end up getting a 0. When I plug a 1 in here, 4 divided by 2 would be 2. And finally, when I put a 5 in here, 5 plus 3 is 8. 8 divided by 2 is 4. So this is what my graph would look like. And again, notice that what the x values were in the function were the exact same y values of the inverse. What the y values were in the function were the exact same x values of the inverse. And that relationship holds true because remember, to find, to get from this equation to this equation, to get from the function to the inverse, all you do is swap x's and y's. And that's what we're really doing here, is that in one equation what the x's are in the function, those will be the y values of the inverse. The y values of the function will be the x values of the inverse. So graphically this holds some important information for us to be able to pull out. Here's what I want you to understand about the graphs. If I asked you, and let's just concentrate on the red graph, that's the function. Is this equation a function? Remember we said for something to be a function, it has to pass the vertical line test. Well, this does pass the vertical line test. If I looked at the blue graph and I said, is the inverse of the function, is that also a function? Yes, it passes the vertical line test. But if I wanted to know without seeing the graph of the function, so if I didn't have this blue graph here, could you tell me whether or not the inverse would be a function without seeing the graph? Yes. All you have to do is see the graph of the function. So if I see the graph of the function, instead of applying the vertical line test, what I'm going to do is I'm going to apply the horizontal line test. So if I want to know, is the inverse a function, I will apply the horizontal line test to the function, not to the graph of the inverse. So again, what I was saying is, and I'm going to erase this, please don't erase it in your notes. If I wanted to know if this blue graph was a function, we would apply the vertical line test to it. And we see it passes it. So I already know the answer is yes. But if I never took the time to graph that, and I wanted to know if the inverse of this red graph, which was the blue graph that I just erased, if that was a function, all you have to do to the function is apply the horizontal line test. And if it passes the horizontal line test, then the inverse is a function. Put that back on here so we can see that. And the reason that this works is because really what you have here when you graph your inverse and the function is you have a reflection along the line y equals x. So that's what I'm plotting on here, is the line y equals x. If I was able to fold my graph paper along that dotted line, what would happen is the blue line would overlap with the red line here. They would lay right on top of each other, and that's all that a reflection is. Because again, we're using this specific equation because we flip-flop the x's and the y's. Again, flip-flop the x's and the y's, and that's the definition of an inverse. So if you want to know if the inverse is a function, apply the horizontal line test to the original function. If you want to know just whether the graph that you're looking at is a function, you use the vertical line test. So you now have to keep straight in your mind, when do you use vertical line test and when do you use horizontal line test. So let's keep in mind the concept of now the horizontal line test when we're dealing with this next example. Here's a function, f of x equals x squared minus 2. I want to know, is the inverse a function? But I don't want to take the time to calculate the inverse, so that means swap the x's and y's, and go through and plot that graph. I want to know just by looking at this graph. So let's make the graph for x squared minus 2. I know that it's going to be a parabola, because the parent function is x squared, and the minus 2 means that it's going to be shifted down 2. And so then I know if I plug in some points here, if I put a 1 in here, I'd end up with -1. If I put a 2 in here, I'd end up with 2. And over here, if I put -2 in, I'd end up with 2 also. And my graph would look like this. Missed that point, but that's okay. So that's what the graph of x squared minus 2 looks like. So now what I want you to do is I want you to tell me, will the inverse of this graph be a function? And so the test that I'm going to do is test using the horizontal line test, because I know that this graph here is a function. If I do the vertical line test, it passes the concept of being a function. But I don't want to know if this is a function. I want to know, is the inverse of this graph a function? So all I have to do is apply the horizontal line test. Notice that it touches here and here. So the answer to this would be no. The graph of the function fails the horizontal line test, so the HLT. So therefore, the inverse is not a function. And it's important that I take the time to write that out, because the concept that you will get confused on in this is you will be looking at a graph and you'll be asking yourself, how do I know if I do the vertical line test or the horizontal line test? If you want to know, is the graph you're looking at a function, you do a vertical line test. So this blue graph is a function. This is a function, because it passes the vertical line test. The inverse of the function, which I don't algebraically, I have not calculated that equation, but I know based upon the idea that this graph is a reflection along the line y equals x. So if I was to fold this this blue graph along that line, what would happen is my graph would look, something like this. It would be a sideways parabola, something like that. This is what the graph of the inverse looks like. So I can clearly see that this graph does not pass the vertical line test, so therefore it is not a function. But I don't need to know what the shape of this graph looks like to be able to tell you that the inverse will not be a function, because the original graph failed the horizontal line test. So I can still say that this graph here fails the vertical line test, so it's not a function. So keep straight in your mind, when do I use horizontal line test, when do I use vertical line test. Let's take a look at a few more graphs. So looking at this graph here, it says, will the inverse of this graph, will it be a function? Well, if I want to know if the inverse of this graph is a function, apply the horizontal line test. It touches it in 3 different spots, so therefore no, inverse is not a function. Don't just write no down, because if you write no down, what are you really answering? Are you answering the part that says, is the inverse a function? Make sure you understand that the inverse is not a function. Is this graph, is the red graph a function? Well, that's when I would apply the vertical line test. And yes, it passes the vertical line test, so it is a function. But I don't want to know if the red graph is a function. I want to know if the inverse is a function. Okay? So, red graph is a function. It passes vertical line test. Will the inverse of this function be a function as well? Yep, passes the vertical or horizontal line test. So, yes, inverse is a function. And finally, looking at the last one, is the inverse of this graph a function? Again, it looks like it's passing the vertical line or horizontal line test, horizontal line test. So yes, inverse is a function.